Ladies and gentlemen, welcome back. This video tutorial is for Algebra 2 for students who are in Chapter/Goal 3. The topics I'm about to teach you today are not technically goal topics. If you do these topics, your percentages aren't increasing. And I know that if you're in Goal 3, that means you're behind and you're getting a little desperate. However, having said that, all of these topics are mission critical for Goal 4, and the software is going to make you do them anyway. So I want to give you guys a quick tutorial so that we know what we're doing. Because we're getting comfortable with exponents, we want to get used to the fact that we can actually manipulate them in traditional ways, such as multiplying them out, which we've talked about in earlier topics, but also being able to understand something particular when you have two terms in a sentence called a binomial. But we'll put that on pause first. First things first, let's get ourselves set up. This is multiplying univariate. Univariate means that there's only one variable. By a monomial, monomial means that there's only one term. So you see here how there's only one term here, the 6y to the 7th, with a positive coefficient. So they're trying really hard to get you comfortable with, ultimately, that, the distributive property. And the distributive property we already know. So 6 times 8 is 48, and we've just spent the entire chapter learning what's y to the 7th times y to the 7th. That's y to the 7 plus 7, which is 14. Next, 6 times 3 is 18. Y to the 7th times y to the 1st is y to the 7 plus 1, which is 8. And then 6 times 7 is 42. Y to the 7th times nothing. Oh, good. So we just copy and paste it right there. And that's all they're really asking you to do in this topic. They do sometimes try to play you by putting it in the back, and you have technically seen that back in Algebra 1 Goal 1, but it's been a while, so just in case, it's still distribution. So 2 times 7 is 14. Z to the 3rd times z to the 5th is z to the 3 plus 5, which is 8. 7 times 9, I can talk. 7 times 9 is 63. Z to the 4th times z to the 5th is z to the 4 plus 5, which is 9. 7 times 7 is 49, and then the z just pastes in. And again, same old, we know what we're doing. This is just fancy distribution. So 6 times 2 is 12. A to the 3rd times a to the 4th is a to the 3 plus 4, which is 7. 4 times 6 is 24. My brain is too fast for me. A to the 2nd times a to the 4th is a to the 2 plus 4, which is 6. I love doing this because they're so rhythmic. 2 times 6 is 12, and then a to the 4th just copies and pastes. And that's all you're doing for these topics. They're very easy to do, very fast to do. Next up, we want to talk about if this here is called a monomial, which means it has one term. So mono means one, term, meal, means term. Mono is one, meal is term. So now if we have a binomial, bi means two and nomial means term. So these are two terms, and that's what this is. Give myself a little bit of space so you can see it in all of its glory. What this means, the software explanation will tell you specifically only one way to do it, which is FOIL. Now, this is actually Ms. Dubois' preferred way of doing it because I can do these kind of computations in my head. Going by FOIL is actually a lot easier for me, and I'll go through that. And I'll do 2 problems with the FOIL, but then another 2 problems. There's a second way to do it, which is the science way. Do you remember your, what are they called? Mr. Milliken, help me. Mr. Milliken in my brain. Punnett Squares, I think. I'm going to pretend that that's Punnett Squares, and I'm sure somebody down in the comments will correct me. Punnett Squares. I'll talk about those in a second. But first, FOIL. FOIL is an acronym because, like everything else in math, there's an abbreviation for it. What this means is first, outer, inner, and last. What does that actually mean? So this is all in terms of, well, terms. So if first means your first terms, what are our first terms? Our x and our x. So what is x times x? X squared. Next is going to be our outer, aka our outside terms. So that's an outside term, and that's an outside term. You can tell because they're on the far end. So what is x times 1? 1x. Inner is your inside terms, right? So there's an inside term. I'll try to do different shapes. There's an inside term. What is 6 times x? 6x. And then last are your last terms. So that's the second one that's listed, and that's the second one that's listed. So it's 6 times 1, negative 6. And that's all FOIL does, is it makes sure that you're getting all of your multiplication combinations without actually accidentally forgetting something. Now we do have like terms here because we have the 1 and we have the 6. So x squared minus 5x minus 6. Yeah, 5x minus 6. And that's your answer. This is one of those things that Ms. Dubois finds really fun because it's very mechanical and it's very rhythmic, and especially where as the human calculator, I love doing these in my head. So first, y times y, that's y squared. Outer, y times 7, so that's 7y. Inner, that's 5 times y, which is 5y. And then last, 5 times 7 is 35. Like terms, what is negative 7 plus 5? That is 2y minus 35. So some kids, it's literally, I would say about 80%-ish kids don't mind the FOIL, but I do have some kids who find that visually very frustrating. So option 2. And when I say option 2, I really do mean it's an option. I fundamentally do not care which way you do it. If there's one of these two methods you like, then do it. What we're going to do is we're going to set these up like our chromosome tables. So we're going to have our W and our minus 5, and then we're going to have our W and our 4. This is a science thing, right? Mr. Milliken, if you're watching this, let me know. So W times W is W squared. W times negative 5 is negative 5W. W times 4 is 4W. And then 4 times 5 is negative 20. Our like terms, we want to keep an eye out for those. There they are. So what do we have? We have W squared minus 1W, because 4 minus 5 is negative 1, minus 20. And I got the exact same answer I would have gotten if I had FOILed it out. Next up, we'll set this one up. So we have, what do we have? We have W minus 2, and then we have W plus 3, okay? W times W is W squared. W times 2 is 2W. 3 times W is 3W. And then 3 times 2 is negative 6. Like terms, keep an eye out for those. So W squared plus 1W minus 6. And there are actually a couple of topics that deal with binomials. They want to get you comfortable with it first. So this is sort of like your beginner level of binomials. And then they tick it up a little bit. Because look at that, the horror, there are 2 variables, except wait, we know what we're doing. Okay, and again, I'll do 2 of them using FOIL. And then I'll do 2 of them using the Punnett Squares. Just give me a second to check a drink of water. Okay, so first, in FOIL, first, outer, inner, last. So F is for first, so 4 times 7, that is 28x squared. 4 times 2, that is 8xz. Again, the variables are not the same, so we just sort of mash them together. Then 5 times 7, that is 35xz. And then the last terms is 5 times negative 2, that is negative 10z squared. Like terms. So what are we left with? 28x squared plus 27xz minus 10z squared. All right, FOIL again for this side. We have 3 times 6, that is 18x squared. 3 times y is negative 3xy. 2 times 6 is 12xy. And then 2 times y is positive. Negative times a negative is a positive 2y squared. Like terms. So 18x squared minus 15xy plus 2y squared. There we go. If you don't like the FOIL, we can do the Punnett Squares. So we have 8x plus y, x minus 5y. X times x is 8x squared. X times y is just xy. 8 times 5 is 40xy. And then y times y is 5y squared. Like terms. So we have 8x squared minus 39xy minus 5y squared. There you go. So you can sort of notice after doing a couple of these over and over is that you're getting the same terms no matter which way you do it. It's just visually which one is easier for you to mentally keep track of. So because of how organized my brain is, I can do it this way. I have other students who are much more comfortable with the science background, and this is easier for them. I do not care which is which. Pick your favorite. We have 4x minus 3w, and then we have 2x and 7w. 4 times 2 is 8x squared. 3 times 2 is 6xw, or is it wx? It doesn't matter. 4 times 7 is 28xw, and then 3 times 7 is 21w squared, like terms. Let's see here. What do we have? We have 8x squared minus 22xw minus 21w squared. So those are two back-to-back terms that deal with multiplying binomials, and you're doing exactly the same thing. You're picking one way to do it or the other, and you're doing it for every single problem. I am balancing out mine so that you can pick your favorite. Am I back? All right, note to self, making, what number am I on? 7 videos in rapid succession leads to lag. Anyway, last topic before I close out and give my laptop a well-deserved rest. Okay, squaring a binomial. So what they do here is they're disguising all of the FOIL stuff that we're doing here. Because here's the thing, and this is what we've been learning all throughout Chapter 3. An exponent means repeated multiplication. So what's happening is we are taking our x minus 5 and multiplying it by x minus 5. Oh, wait, that I know how to do. That's exactly what we've been doing. Okay, and now Ms. Dubois is going to show off a little bit. That is x squared minus 5x minus 5x plus 25, which is x squared minus 10x plus 25. Boom, done. And again, Ms. Dubois showing off a little bit. I do acknowledge that, but that's because I know how to do my FOIL and I know how to do my Punnett Squares. So there's not a lot of thought required for Ms. Dubois because I've been doing it, so often. For you guys, go through the effort, do your first, your outer, your inner, your last, or do your Punnett Square, either or. This one, that is 4 minus 5u times 4 minus 5u. All right, so that's going to be, Ms. Dubois is going to do this in her head live and in person. So that is 16 minus 20u minus 20u plus 25u squared. So that is like terms, 16 minus 40u plus 25u squared. So all this is doing is getting us used to the fact that when you want to multiply a binomial, they tend to hide it on you by doing a square. So I'm really going to show off now. This is 25 minus, let's see here, 10x plus x squared. And then this will be, what's going to happen now after a while, this I actually did not do the multiplication in my head like I did up here and up here. I actually happen to know that when you take two things and square them, so if I have a plus b squared, that's the most abstract I can get, random thing and random thing quantity squared. What that means is I'm going to get a squared plus 2ab plus b squared. It's okay if you don't recognize this off the bat. It takes a while. When I was in high school, Ms. Dubois took a while to figure out the pattern for this, and I was outright told the pattern to start. But what's happening is I can take my first term, square it, multiply these two together, double it, and then square my second term in order to get my final answer. If this is a giant question mark for you and you're like, what, Ms. Dubois? Don't worry about it. Do your FOIL or do your Punnett Square. Either or. Again, I don't care. What this is for mostly is for the kids who can notice the pattern and then it saves them a little bit of math when they're doing this in their heads. All right, I am giving my dinosaur of a laptop a well-deserved break. As always, stay happy, stay healthy, stay safe. See you in the next one.